Hello, everyone, and welcome to another episode of Build St. Louis, the regional podcast that continues to capture and share the very heartbeat of construction. I'm your host, Kerry Smith, owner of Construction News and Review, or CNR magazine. And we're excited today to welcome two experts on a specialized material that I think a lot of us that are maybe work tangentially to the construction industry aren't that familiar with, and that is lightweight cellular concrete. And here is our guest today to tell us all about it, how it's used, and the results that it produces are Jane Megown, president of Elastizell of St. Louis, and Mike Megown, Vice President of Pre-Construction for Elastizell of St. Louis. And I just want to welcome Jane and Mike to the program today. Thank you so much.
Thank you.
Oh, thank you so much, Kerry. We so appreciate this opportunity, and thank you all for listening. So thank you.
You bet. So it's really interesting to me. And I wanted to mention, too, that Jane, that Elastizell of St. Louis, that the firm is a DBE and WBE certified firm specializing in the mixed design and application of this material known as lightweight cellular concrete. And I wondered if maybe some of us have heard of it by a different name, or is this usually how the material is specified?
So there's many different names, and depending on states, various states go by different names. Some of the names would be low density cellular concrete as well, or LDC. And then there's the LWCC, lightweight cellular concrete. There is a low density cellular concrete fill, or LD. There is lightweight foamed concrete fill, a lightweight insulating concrete. So
Oh, wow.
It goes on. I'm sorry, I'm gonna give you a whole list because it's like it depends on we've seen it in so many phrased so many different ways. So there's cellular concrete fill, lightweight fill, cellular concrete grout, engineered fill, low density flowable fill, controlled density fill, low density cementitious fill, embankment fill. In some states can be specified as controlled low strength material. Yeah, it's similar to a flowable fill. A lot of people see it flowable fill. A lot of times we will be a replacement to that. We're very similar to flowable fill, but we don't contain any sand.
Okay. I probably jumped to question number 2, and just to maybe walk us through, because to be transparent with our listeners, when I first sent questions to Jane and Mike, they knew I had no idea what it was because I was asking you questions about structural concrete. But if you could just explain a basic or high level to us, how is lightweight cellular concrete different than maybe concrete that a lot of us might initially be thinking of?
Well, I'll kind of tell you how it's made. First of all, it's a mixture of Portland cement, water, fly ash, and a proprietary foaming agent. So this foam has the appearance of shaving cream, and this foam is injected into the material at various quantities, and that's what controls the density. And so this is the concrete it's mixed and batched on site, and can be designated for densities from 20 PCF to 120 PCF. It is self-leveling and it requires no compaction.
And real quick, for anyone that is way outside the construction industry, is that pounds per cubic foot? What's PCF?
Yes, that's correct. Okay. So you know
very good. Very taking a shot at it. Compared to what would be, and I don't want to keep mentioning the other type of concrete to be confusing, but when you said 20 to 120 pounds per cubic foot, like structural concrete would be in the thousands, wouldn't it be?
Yeah, Mike, you want to address what the difference is and all that?
Yeah, and just to put it in perspective, the cellular concrete sort of lands between geofoam, which is expanded polystyrene, and concrete. And so you've got geofoam, really lightweight, not really strong, but provides a good building block. You've got the structural concrete that is going to be 150, probably the minimum I've ever seen is 3,000 PSI compressive strength. Whereas the cellular concrete at the bottom end, the 20 PCF, is going to be 10 PSI compressive strength, which comparing that to geofoam I think geofoam is 2 PSI. So we're at 10 PSI, and then up to the 80 PSI, we're 300 pounds per square inch minimum. It's going to be closer to 1,200 PSI tested out. And so again, we land right in between that geofoam and both from a weight perspective and a strength perspective, landed between the geofoam and structural concrete.
We're about a fifth. Lightweight cellular concrete is about a fifth of the weight of concrete. The applications are different too. Like I know we touched on a little bit, and Mike can kind of go on this too about the different classes that we're specified in, and then what structural concrete is used for, and the type of applications we're used for, because they're totally different applications. So, Mike, did you want to talk about that a little bit?
Yeah, and I don't want to bore the audience too much with this, but from the construction standpoint, there are specification sections where concrete is under specification. It's a class 3 material. The cellular concrete oftentimes is under class 2, which puts it as a soil replacement versus a concrete. Although I will say that you can see it under the class 3, under the grouts. It's such an oddball product that there are multiple specifications this could be under.
Okay. So you may be like partnering on jobs with people that are deep foundations or that are excavators or people. Is that kind of, not to jump ahead because I know you're going to give us some great examples of projects, but do you kind of come in sometimes at the very start?
Sometimes we are at the beginning, sometimes we're at the very end, and it just all depends on the project. We are all over the place, and with every type of general contractor, from the tunnelers to the high-rise builders.
Talk to us a little bit about the types of projects, or, you don't have to share the name unless that's helpful, but just the types of projects and the application specifically, just to show people that it is a wide range of applications and purposes.
Okay, Jane, you want me to take that?
Yeah, go ahead.
Okay, so we're everywhere. And oftentimes we're coming in as a VE alternative that the engineer hadn't thought of. But one of the most common that we see is the backfill for a mechanically stabilized earth wall. And I'm not sure if that's something that everyone knows what it is, but these are mechanically stabilized earth is an MSE wall. They're used highways, rail lines, bridge abutments. Just about everybody's driving by an MSE wall at some point if they're driving down the highway. And these are panel walls held in place by straps that go back into the fill, typically with an aggregate of some sort, whether it be earth or sand on the inside. But when you get into areas where you have poor soil, or there could be something buried underneath the work zone, so it might be a large brick-lined sewer from 150 years ago that you can't add any more weight, but they need elevation, they will take cellular concrete, and instead of putting sand in between the MSE panels, they'll go with the cellular concrete, and we can gain basically 4 feet in our elevation for what would be 1 foot of a sand elevation. So we can really get higher without adding additional weight to the project.
Oh, that must be great if you're partnering on, like you said, with transportation agencies or municipalities, or just using that as an example with thoroughfares and highway bridges and stuff.
DOTs and a lot of the rail lines, or whoever might own a rail bridge or even the highway, we're being asked to travel regionally, at least from Ohio to Omaha on various projects.
Wow, that was going to be my next question, because I know with like another form of concrete, they would have more of a finite service territory. But I was thinking, as you were saying, that you have a pretty portable situation in terms of where your customers are.
Well, talk about another project that we did in Nashville in a second, but Jane, you might know more about this than I do, but there might be 5 or 6 of us across the country that have got the capability, and it really gets into how much volume you can pour, and the equipment is expensive, and you've got to have a lot of knowledge to do this. It's really operator dependent. They've got to be comfortable with it, but there might be 5 or 6 of us across the country that can handle these big projects and have the knowledge to do it. Again, from the equipment side and from the operational side. They're not easy to do, and they take a long time.
I didn't realize that how unique really Elastizell is. So that's
this is an odd animal, and I've been on some projects that you see a wizened old superintendent that comes jogging down the street as we start pouring, saying, "Boy, I've heard of this stuff, but I've never seen it."
You must have a really skilled, on the operational side, a skilled crew, unless, like, if you're in a market that's farther from your headquarters in like Nashville, are there sort of subcontracting firms that have this knowledge, or do you kind of self-perform?
We self-perform everything. We'll hire local
Okay.
neighbors, and so we typically use machine operators and laborers, cement mason if we need it, but the cement masons and the operators, each of our key guys has got 5 years minimum experience.
Wow.
Yeah, we've been really blessed with our crew. Our operators, his first job at 16 years old and has been with us ever since. We've got unbelievable expertise and knowledge. So we're very blessed with that. So yeah, we've been able to do the very large projects and travel across the country because of that expertise. So
Right, and 2 guys training underneath him just so we can carry it on.
yeah.
Oh, that's great. Tell me about the Nashville project, what you were going to talk about with that.
Yeah, and this one was just interesting because we happened to be doing another project on Broadway in downtown Nashville. This company saw us there and thought, boy, this will be perfect. And they asked us to come look at their site. And this was just there's a full city block, downtown Nashville. And they built a parking garage, I'm going to say is about 30 feet below road level. And they'd had the foundation poured and again, real tight constraints, but they had basically a gap that was about 30 feet deep, 6 foot wide, that they weren't sure how they were going to fill up other than putting gravel in all the way around this building and compact it. And we were able to give them a good price, came in 2 weeks, we filled it up and we're out of their hair and they were done. And it just made their life so much easier. I couldn't imagine how they would have ever gotten that much gravel in and compacted in that tight space.
That's a great example. And I was going to ask you about the cost. And I know, sure, it depends on the job and where it is and the quantity and all that. But that's a perfect example, I would imagine, of, you've got a project budget and they've got to meet it. And you could come in and is that something that's an attractive selling point of lightweight cellular concrete?
Correct me or speak up, but in many cases it is. We might come in with a higher unit price, but in the end, we're saving so much time and we're saving so much of their own labor or some other subcontract labor. So if we try to compare crushed limestone to cellular concrete, it's never going to compare. But when you compare the in-place product or the finished product, oftentimes we come out shining. And Jane probably know more about that, the rail project in California, but what was that, a 40% savings?
I think that was a project. We didn't actually do that project, but it's been highlighted in the industry. And I think they saved like 40. I don't want to tell you the wrong statistics.
Oh yeah, no, or approximately.
Yeah, it saved, I think, was it 45 million, Mike, or something?
Yeah, and this obviously is a large project. This is the largest, I think to date, this was the largest singular cellular concrete fill, at least domestically. And
wow.
Again, I think it was a 40% savings. And again, I'm going on memory. I think it was 4 months that they saved.
4 months. Yeah, 4 months and large, I think it was 40 million or something like that dollars it saved them. If you look at the other materials that we would be an alternative, would be rock or soil, sand, flowable fill, geofoam. Maybe not the geofoam, but those not flowable fill, but let's say rock, sand, and soil. The material is going to be less material costs, but you've got to look at the whole value of the project that we can provide. So we will, we have greatly improved the work schedule compared to standard backfill. We would be 80% less trucks. So you're thinking like less congestion at the work site. That's less fuel cost. And then also we're very pumpable. So we can pump within 5,000 feet of the project. So a lot of these projects where it's very tight confined workspace, we can pump long distances. So we will park off site and pump so that we're not in that work site, that tight workspace, congesting that up. So other trades can be working alongside as we are. So it really improves the work schedule. So that's a good savings. We don't need any compaction, which that speeds up the work schedule. Just from a safety standpoint, just not having all the trucks that we need, and that helps. We can pump about 600 to 800 cubic yards a day. So it's a quick installation. And we do about 3 to 4 foot lifts a day.
If I were out there on the job site, would I see like this big, long, what diameter tube with stuff going through it? Or what does it look like when you're kind of parked off the job site and you have this network of hoses or however you do your magic?
We try to keep the hose hidden. So it's hidden just because we don't want people having to walk over it or drive over it. And so make it underneath an overpass, up along the bridge, and into the workspace, but it's typically a 3-inch hose.
Wow, it's very narrow.
It comes out the consistency of like a milkshake when it comes out. So
It is really fluid.
and it completely fills all the voids, which is very good, especially when you're doing like a pipe. Mike, maybe you're going to go into some of the pipe abandonments and the like, but were you going to go into that, Mike, or?
Yeah, we haven't even touched on, you get to see it, but there's a lot, I don't want to say half of our work, but half of the projects, if not more, are smaller underground projects. You have a pipe abandonment. And again, just for a quick education, if an entity, an owner abandons the pipe for whatever reason, there are federal, state, whatever regulations on what you have to do with that pipe. And it's basically, you either have to fill it in with grout of some sort, or you have to monitor forever. And so the option is to fill it with whatever they can fill it with. And with the cellular concrete, it is so fluid, you can pump this. We just filled a job in underneath St. Louis Airport runway that I think it was almost 2 miles of pipe that we filled from one injection point. And to do that with flowable fill, I don't know how you'd push it that far and still have anything but water coming out the other end. But it's just an easy option instead of having to go out and dig up spots at various points in the runway to have an injection point. We just go to one point and fill it until it's coming out the other end. And then, as James mentioned, it's going into every nook and cranny that was in there before it comes out the open end.
Would we ever see it anywhere? Like you mentioned the panels. I'm trying to find my notes here on the panel walls, like along an interstate or something. Would ever be something we'd see, or would it be painted a different color, or is it pretty much the invisible kind of solution?
It is always buried or underground, which is horrible when I'm trying to brag to friends or family about projects that we've worked on. Like, where is it? Well, it's underground.
They got to trust you, right, when they drive by. That's so interesting to me. I don't know if this is an applicable question, but when the past makeup, I guess a number of years, 3-4 years, when the supply chain was just getting funky for so many contractors, was this something was that a challenge in any way for the ingredients that comprise what you're doing, or were you not really affected as much?
Jane, you want to hit it, or do you want me to take that?
We were affected somewhat, but then the geofoam was harder to get, right, Mike? And so a lot of times there was more opportunities for us because you couldn't get geofoam, or the price was just so astronomically high at that time. So sometimes there was more opportunities for us during that time.
Yeah, and actually, we had a slow period after that the COVID pandemic started of about 2 or 3 days. And then all those infrastructure projects that had been put on hold because it was hard to get the space or the traffic was too much, all of a sudden, all those projects were ready to go. And so we
really
slow days, and then we've been going gangbusters since. But on the material issue, as geofoam was going crazy and the pricing was doubling every month, cement got to be problematic. And there was at St. Louis, we were good, but regionally, Chicago and Ohio and other areas, cement was very difficult to find. And cost-wise, it's still high.
Wow. That's good to know. Where's the bigger education process, I guess, on the project team in terms of remembering that this is a very viable option? Is it owners that need to understand more about it, or is it the general contractor, or yes to both?
I would say yes to both, and a big yes to the structural designers. So we need to get out to more structural designers, let them understand it, at least have this arrow in their quiver when they get to that. And this is not going to be a product that's going to be used everywhere. But when they get to that issue that they think, how am I going to get around this? They need to at least consider something like cellular concrete as a possibility.
That's fantastic.
Yeah,
Jane, did you have something else you wanted to share?
I was just saying the architecture and engineering area, we need to do a better job of educating them and letting them know and get involved in the design build. Because there's been so many times that something's been built and then I'll tell them, oh, we could have done that. I'm like, oh, shoot, you would have been such a savings, or wow, we had this problem and you would have been a great solution. So that's kind of my job, is try to get out there and educate and let people know what we can do. And we're very transparent and open and honest. And if we're not a good solution, there's something better, we're going to tell you that, because we treat your project as our project. We're always available to answer any questions, to help you if you want to say, hey, what do you think? How much would this cost? How many days would it be involved in doing this? We are more than happy to help any way we can. We also have Tom Bittman, who's not on this call. I didn't want to have everyone on here fill up the whole screen, but he's been with us for over 35 years, has unbelievable amount of expertise, and just a really genuinely nice guy, and is always there to help as well. So if you have anything that you need or any questions, anything we help you out, we're always here to help. There's no cost to anything that we do to help you and provide you with input and that. So
That's fantastic. Well, the time went by so quickly and I could have peppered you with more questions, but I'll do it the next time I talk to you. This has been great with Jane Megown and Mike Megown, President and Vice President at Elastizell of St. Louis. And again, a DBE, WBE certified firm specializing in the mixed design and application of lightweight cellular concrete. And if you do have any questions, I hope you will reach out and touch base with Jane and Mike. And it's just been a pleasure learning from you both today. Thanks so much for being
Yeah.
on Build St. Louis.
Thank
we
you.
certainly appreciate it. Thank you so much. Thank you, everyone.
You got it. Thanks, everyone.